In this video tutorial, we will study the principles of operation and the design of linear and rotary potentiometers. A potentiometer is a variable resistor whose resistance can be adjusted mechanically. Potentiometers are used as a voltage divider for its smooth regulation. In order to understand how the potentiometer connects to Arduino, we need to understand how it works. To do this, let's imagine a simple scheme. Let's take an ordinary battery, a resistor, and an LED. If we connect them, we will see that the LED will light up. You also should know that ohm is the unit of electrical resistance. In this case, we have a 100 ohm resistor. If we increase the number of resistors, the current resistance will also increase and the LED will become dimmer. But if we change the connections like this, then we can control the brightness of the LED. Now, if we want flexible control of the brightness of the LED, we need a resistive material. That is, a material with high current resistance, which is also called a potentiometer. There are many different potentiometer designs, but all of them can be divided into two main groups, which differ in the trajectory of the sliding contact. This trajectory is determined by the shape of the resistive material. For example, this is a potentiometer with a linear movement of the movable system, while this has circular movement. Potentiometers are used as stepless regulators, for example, as volume controllers, in servo systems, and also as slide controls of various voltages. Now let's move on to practice. Let's figure out how the potentiometer works with Arduino and how it can be used to control the brightness of the LED. Let's first connect the potentiometer to Arduino. For this, we connect the two outside contacts, one to the 5V Arduino and the second one to the G&D pin. And it doesn't matter which of the outside contacts we connect to which of the pins. The central contact is connected to the analog pin A0. Now, how does it exactly work? Arduino gives the potentiometer 5 volts and receives back from it from 0 to 5 volts depending on the position of the slider. Then it compares the two numbers and converts them into a value from 0 to 1023. Alright, let's look at it in more detail. For this, we should open the Arduino program and write the commands. Open serial port and set baud rate to 9600. Create a variable to hold the potentiometer values. Read the value of A0 and store the data in var. Send data to computer via USB cable. Now we can run the code. And everything's working. We see that the value smoothly changes from 0 to 1023 in 1 unit increments. And before your eyes, an analog to digital conversion takes place. The voltage from 0 to the reference voltage is converted to a value from 0 to 1023. This means that we can use the potentiometer to adjust anything with just over 1000 increments, which is pretty good. Let's now try to control the brightness of the LED using a linear potentiometer. We will use module number 15. The connections are as follows. First, connect the potentiometer to the Arduino as we did before. One pin to the Arduino's 5V and the second one to the G&D pin. Also, we connect the central contact to the analog pin A0. Now, let's connect the LED. As you can see, there are already 10 pins and G&D in module number 15. Now, we just have to connect them correctly. We close 10 pins through a resistor so that the LED does not burn out, and G&D is connected directly to the minus of the LED. Now open the Arduino program and write the commands. Open serial port and set baud rate to 9600. Set the mode for the pin to output and create a variable to hold the potentiometer values. Create a variable to hold the converted values. Read the value of A0 and start the data in var. Send data to computer via USB cable. Since the value from the potentiometer comes in the range from 0 to 1023, we need to convert them specifically for the LED because the LED only accepts data from 0 to 255. So convert the data from 0 to 1023 to 0 to 255 and store the finished data in var2. Send the converted data to the computer. Send the converted data to the LED. Finally, let's run the code. What do we see? With the help of a potentiometer, we can smoothly control the brightness of the LED. Everything is working. Congratulations! We have gone through all the basic principles of the potentiometer and have put it into practice.